Hello, for this experiment we used extraction to separate a compound into three parts, its acid, neutral, and/or its base. After separating out the compound, we measured the amount recovered of acid, neutral, and/or base, and then we tested the melting points using a MELTEMP and comparing them to compounds that we knew the identities of to determine the unknown compounds. We were given a sample that was in its solid form that was nonpolar, so we were not able to dissolve it with water because water is polar, and we therefore used ether, which is also nonpolar, and like dissolves like. So when the solid was added to the ether, it formed a solution, and then we were ready to start separating out that solution. We started with our base, and we wanted to separate it out, so we added hydrochloric acid, because hydrochloric acid will donate a proton from the acid to the base, which will neutralize it, making it an ion and forming a salt. When we do this, we get an aqueous layer that has water from the neutralization process and an ether layer that forms on top. The ether layer forms on top because it is nonpolar and the water layer is polar, and they do not like to mix. The ether layer forms on top because it's less dense and it floats on top of the water. We take the sample and we take out the bottom aqueous layer with a pipette, and we put it into a new tube to do a confirmation test to see if a base is present. And if a base is present, we want to get it back into its solid form so that we can do a melting point test on it later. This is what the base looks like after it's been separated out. It is important to point out that the student made an avoidable error here. The error was on behalf of the student. As they were pouring and mixing, they spilled onto the outside of this container. Ether is highly volatile and evaporates immediately, and the sample crystallizes on the outside. The student is not going to be able to get this back. It's going to have to remain on the outside and be cleaned off, and this is going to lower the recovery at the end of this experiment. Since we need the sample to be a solid for the melting point, we are going to re-add some base, and this base is going to bind to the hydrogen here, the extra one that was donated from the acid, and that's going to form water, and it's going to reform the original base, if the base was even present. So, after adding base to the solution, we check the pH level on litmus paper to see if it's basic enough, and if it's basic enough, a precipitate will form if base is in the solution, and this does not happen, so the student does not have a base. And we move on to the acid portion. To determine whether or not there's an acid, we add a base to the solution. That base will take the extra hydrogen here from the acid, because acid is a proton donor. It will form water and an ion. Again, ions are soluble, therefore it will form a solution, and that will be separate from the ether. We pipette it out and put it in its own tube, as seen here, and then we add the acid HCl back into it, and it does the equation you see down here, where the ion will take on the hydrogen from the hydrochloric acid and form the original acid again plus salt, and then we test it to see if it will form a precipitate by adding it in excess. And as you can see here, it does form a precipitate. So that means that there is an acid present. We use a Hirschfunnel to remove any excess liquid, and that way we are left with just the acid, so that later we can weigh it to see the recovery. There was an unavoidable error at this step, because the crystals formed in more of a powder-like substance, and the powder was left on every piece of equipment that was used. It was on the spatula, the Hirschfunnel, the filter paper, we tried to get it off, but you couldn't get everything, and that lowered the amount of acid that was actually recovered at the end of the experiment. At this point, all that's left is the neutral component. We don't actually have to do any chemical reactions necessarily for this. Ether, again, is highly volatile, and when put on heat will evaporate very quickly, and so all we have to do is evaporate the ether gently so that no accidents happen, and we'll be left with neutral crystals that are already dry. So now we're left with the crystals that we were able to recover. Again, we were not able to recover a base because no base was present. We got precipitates for our acid and our neutral layers, and then we get to check them in the melt point temperature apparatus. We use a capillary tube and we pack it with each of the samples and we test them individually, and we compare their average melting points to documented averages of the samples that are known. For our acid, we had an average of 127 degrees Celsius, and that was our experimental average versus the known average for the compound tranexamic acid, which is 133 degrees Celsius. It was a pretty safe bet to say that we had tranexamic acid because melting points will always be lowered if the compound is not pure. And obviously, throughout this experiment, it would have been very difficult to keep the compound pure if it was already pure to begin with. For the neutral, we had an average of 91.5 degrees Celsius, and we compared that to the known average of benzyl, which was 95 degrees Celsius. Again, it was a safe bet to assume that our neutral was benzyl. And when checked with the professor, these were both correct. The recovery for this experiment was only 57.88%, and again, that was due to the student spilling some of the sample, which was an avoidable error, versus the unavoidable error of the sample being stuck to different apparatuses. And there was nothing that the student could have done about that. In conclusion, extraction is a method of separating out different chemicals using their solubility properties and their densities. Ether is a less dense nonpolar molecule that will rest on top of the more dense polar molecule, water. So we separated out our solution using ether and then allowed them to form two layers and separated out those layers and tested them using confirmation methods to see if an acid, a neutral, or a base were present. In the end, the student obtained an acid, tranexamic acid, and a neutral, benzyl.